each representing a ratio, are made equal, as in an equation, the result is called a proportion. For example, A over B is one ratio, and if we write that that equals to another ratio C over D, then the entire statement is called a proportion. Notice that there are 4 parts to each proportion. 1, 2, 3, 4. These parts are called proportionals. And this one in the upper left-hand corner is the first proportional, this one the second proportional, this one the third, and this one the fourth proportional. Here are some basic laws of proportions. If A over B equals C over D, then 1. A times D equals B times C. Notice how I determined that. I multiplied across here, followed by multiplying across here. For that reason, that is referred to as the law of cross product. Or cross multiplication. So cross multiplication is a term that only applies when you have equations consisting of only 2 fractions, one on each side of an equal sign. Again, number 2, if we start with A over B, is equal to C over D. It is also true that A over C is equal to B over D. And this is called the law of alternation. And 3, if A over B equals C over D, then by taking the reciprocal of A over B and writing B over A, followed by the reciprocal of C over D and writing D over C, then this is also a true statement and is called the inverse law, or the law of inversion. There are other laws of proportions, but we will not discuss any more of them. Proportions are applied in problems when 3 proportionals are known and the 4th is to be calculated. For example, I will now show an application of proportions to an interpolation problem. I will take some numbers out of a statistical textbook, several numbers out of this table. For example, in the first column, call it n, we have the numbers 0.8, 0.9, 1.0, 1.1, and so on. To the right of these numbers, we have the following. Opposite 0.8, there is 0.66640. Opposite 0.9, I have 0.7163. Opposite 1.0 is 0.7616. And opposite 1.1, there's 0.8005. So, in this table, supposing now we wanted a value for p when n is a number that is not part of the table. For example, find the value of p if n is equal to something like 0.96. Now the value for p for 0.96 is not in the table, and consequently finding numbers like that within given numbers is referred to as interpolation. And the value for p is found by dealing with differences and setting these differences into a proportion. Let me illustrate. I have for n the value of 0.9. Opposite it, I have for p the value of 0.7163. In between 0.9 and 1.0, I will leave a space for 0.96. Opposite 1.0, the number entered is 0.7616. This quantity then has to be found. What we do is this. We take the difference between here and here, we'll call it D1. We'll take the difference between here and here and we'll call it D2. Related to this difference should be a corresponding difference for the difference between these two quantities. And so therefore, let's call that the difference D3. Similarly, for the difference between 0.9 and 1.0 is a corresponding difference between these two, which we will call D4. D stands for difference. Now the proportion which relates the numbers on the left with the numbers on the right is the following. D1 is to D2 as D3 is to D4. And so what it simply requires now is that we put differences into their proper places within the proportion, and we'll have 3 of those quantities. The 4th one will not be known and will have to be solved for. So let's do that. The difference, D1, between 0.96 and 0.9 is decimal 0.6. The difference D2 between 1 and 0.9 is equal to 0.1. On the other side, D3 is not known. We can either put an X in that position or D3 if you want to. For D4, the difference is 3, 5, 4, 0 decimal. If we take the cross product of this proportional, we have decimal 1x over here equal to decimal 0.6 times decimal 0.453. So using the calculator to work out the right-hand side, we have that 0.06 multiplied by 0.0453 is equal to 0.002,718. So 0.1x is equal to that amount. And then x is equal to this divided by 0.1, and that'll become 0.02718. This x is a difference that represents the change from this quantity, 0.7163, to the next quantity in this table. Therefore, if n is equal to 0.96, then p will equal to 0.7163 plus 0.02718 is finally equal to 0.74348. Next is variation. Physical laws of science are often stated in English sentences. I will deal with methods which translate English sentences about physical laws into working formulas, since these sentences are about variables. We can classify these sentences of physical laws into types. Type 1 is referred to as direct variation. The key phrase in the sentence dealing with a physical law is that a variable, some variable in it, quote, varies as, end of quote, another variable. There are several other phrases which essentially mean the very same thing, that is, direct variation. And they are: varies directly as, or varies proportionally to. Something varies proportionally to something else, or is directly proportional to. Depending on the author's taste, which one he might use in his text. Every phrase, no matter which one is used, is an example of the same idea, which is a direct variation. For example, distance varies directly as time. I could have said simply, distance varies as time, or distance varies proportionally to time, or that distance is directly proportional to time. It all means the same thing. If the letter S is used to represent distance, and T represents time, or variable, S represents the distance and t represents time, then the formula which represents the English sentence is S equals KT, where K is a constant of proportionality. Or sometimes called the constant of variation. Then the formula is S equals KT. The next type, we'll call it type 2, is inverse variation. The phrase found in an English statement regarding a physical law will have this phrase in it: a variable quote, varies inversely as another variable. Other phrases which mean the same thing are varies indirectly as, or is indirectly proportional to. For example, volume varies inversely as the pressure. If you think about what the sentence is saying, it goes something like this: that if you're given the volume, such as a piston and a cylinder arrangement, then as you increase the pressure in that closed cylinder, the volume will decrease in size. If P represents the pressure and V represents the volume, then the formula which represents this law is V equals K times 1 over P. The reciprocal here of P indicates inverse variation. Or you might write, which is also acceptable, V equals K over P. The constant of proportionality K must always be part of a variation formula. The third type is referred to as joint variation.